Alright guys, I was a little bit disappointed with the quality of work I got in terms of that the video response to the question I gave. But I'm going to run through it and then set another one for you because I was not happy with the number of persons that submitted and also how you went about answering the question. There wasn't much thought given into it, with the exception of one group in particular. So we need to get through that. Okay, now it says a ship sailed 17 kilometers in an easterly direction from a port. So the first thing I need to do is identify the port, which is that. Now, of course, the north line is going to go through the port. So we're going to establish a north line. Very, very simple. So we're going to put the north line here. Most of you got the diagram correctly. It is a working out part that stems from your acquisition of the information from grade 10 and using it now. But anyway, the ship sailed 17 kilometers in an easterly direction. So east is going this way, and again the importance of the compass rules. So this would be 17 kilometers east, going that way. And of course, if you're traveling east, then the angle between east and north is simply 90 degrees. Now the ship is now here, but it then sails 11 kilometers in a southerly direction. So I'm just going to indicate that. So the ship is now here, and this distance is 11 kilometers. Now the question is asking for the bearing of the ship from the port. So I need to first of all connect the port to the ship. So I'm just going to draw a line that connects P to S. Now before I proceed, if you go east and then south, then clearly this is 90 degrees here, which a lot of groups did not indicate, which is a little bit worrying. East and then perfectly south, that would be 90 degrees here. So we're looking at a right angle triangle there. We're dealing with trigonometry, so triangles must be generated. Now they're asking for the bearing of the ship from the port. So they're asking for this entire angle right here, coming around like that. That's the angle that they need. And obviously that angle is, this is angle on a straight line here. So this would be 180. So obviously that angle is a little bit less than 180. It's more than 90 obviously because this would be 90 here, but it's less than 180. I see one group giving me over 300 degrees. Obviously we're looking at this diagram because clearly this angle cannot be over 300 degrees. If this is 180, then clearly this bearing here is less than 180. So they're asking for the bearing of the ship from the port. Now we already know a part of this angle because we have 90 degrees here. So from here to here is already 90 degrees. I'm just putting in 90 degrees there because that 90 degrees is not going to be the entire bearing. So I didn't bother to put in the three figures. So I'm just indicating from here to here, that is 90 degrees. Now to find the entire angle here, which is going to be the bearings, what we need to do is to locate the angle inside of the triangle, which is this angle here. I can call this theta. And that is what we need to use a triangle to do, to generate theta. So again, most of you did the diagram correctly. This is where the ship is now, so it couldn't have indicated that the ship is still here and then there's another letter here. It's confusing. So the ship went 17 kilometers east and then 11 kilometers south. So the ship is currently here now. Cannot be anywhere else. It is here. Alright, so the bearing is what they ask for, the entire angle, but we know a part of it is 90. So if we find theta, which is the angle inside the triangle, then we're good to go in terms of finding the entire bearing. We just simply add 90 to whatever we find theta to be. But we're dealing with a right angle triangle. I think one group went ahead and found the hypotenuse and then used sine rule, no problem. But that is a longer route. All you have to do is recognize that it is a right angle triangle. The side opposite this is the hypotenuse. Now, all I need to employ now is a trig ratio to determine what theta is. So if I'm looking from theta, then this side is going to be opposite and this side is going to be adjacent. Okay? So the trig ratio I need to find theta deals with opposite, seeing that we have a length for opposite, and dealing with adjacent, seeing that we have a length for adjacent. So the trig ratio that incorporates opposite and adjacent is going to be tangent. So we need to employ tangent to find what theta is. And that is simple business. So I'm going to just slide this over a little bit and proceed. So tan theta would simply be opposite over adjacent. Okay? We're not learning things in math to put it aside when the CSEC exam is not on us yet. So we have to use the things that we've learned and don't forget them. That's the reason why we went through all of that in grade 10. So tan theta, which is what we find the angle inside the triangle, is going to be equal to 11 over 17. Okay? And you need to go ahead and find whatever 11 over 17 is. So we're simply going to divide 11 by 17 on the calculator. So on the calculator, of course, ensure that the screen is cleared. Always do that before you start using calculator. And we're going to divide 11 by 17. And remember, to increase accuracy, stick with 4 decimal places in the body of the working out. Some persons started rounding off a little too early. So it's going to be tan theta is going to be equal to 0.6471. So theta will be equal to the tan inverse of 0.6471. And that is simply going to be, so the shift tan inverse of 0.6471, that is going to give us 32.9 degrees, so to speak. So it is 32.9 degrees. It's an angle, so I'm going to go to 1 decimal place for now. Now, I know what theta is, so all I need to do now is add theta, which is 32.9 degrees, to this 90 degrees here. So 90 degrees added to 32.9 degrees is going to give me, I believe, 122.9 degrees. Now they ask us to write the bearing to the nearest degree. So therefore, the bearing of the ship from the port is simply to the nearest degree, it will be 123 degrees. And this is what you should have done to answer this question. Very, very simple. And you guys just need to apply your previous knowledge. Just look at the question and answer accordingly. All right. So I want you guys to transfer this correct solution to your notebook, and then I'm going to post another question for you to do, or perhaps 2 questions, and I'm going to ask you to work in groups. All right. Discuss the question, draft it out, and then present it. All right. So I hope you guys found this video insightful, and I'll see you guys on the next video.